be over, but that's okay. All will be well. So, as always, quick logistics update. Let's make certain my stream's working so I don't have to repeat it all. Not to get done. All right. So, we are finishing up the optics slide today. That's our last thing of content. If you notice, we finished with 5 or 6 slides left to go. Not really much at all. 1, 2, 3, 4, 5, 6. Look at that. 6 slides left to go. Be no problem. And then that's it. That's it content-wise. Which gives us a nice we have a little bit of time today. We'll have all next week. Basically, we'll just be reviewing stuff. I'm going to send out an announcement with all these details, but next week there won't be any clicker questions. So it's one of those, if you want to come and get some review, I will be here doing review stuff. If not, there's no penalty as far as clicker questions are concerned. On Tuesday, my plan is basically to do an overview of everything we've covered. So we've covered 11 weeks worth of stuff, and I'll go through and highlight what the main things we've learned are. Things you need to remember, so kind of we'll have a slide for each one of those. Basically like a main point slide for every single week. That'll be largely conceptual in terms of what I'll be mentioning. Make sure you remember that. Make sure you remember that the direction electric fields are due to various charges. Positive charges they point away, negative charges they point towards, that kind of thing. So I'll make a nice thing about that. That'll get posted. And then I will also, and I'll try to post that before as well, but I'll talk through it. As usual, add tidbits here and there, draw some pictures, that kind of rigmarole. On Thursday will be a lot of problem solving. Actually, the thing that's probably a bit more challenging, make certain I do a good amount of ratio problems because I think those have been pretty commonly challenging. I will also highlight the problems. I'll quickly kind of talk through and maybe solve some of the problems that are the most commonly missed in the tests. One of the beauties of scanning the scantrons myself is I can easily see which questions were the hardest, the ones that people missed the most. Often small mistakes, easy things for us to fix. You can almost guarantee that some of those problems that are the most commonly missed will then show up again on the final, because that means that we want to learn from those mistakes. The questions themselves, I think, weren't mistakes. I think that's the concept. So that's kind of a key point as well. Reminder to you all, as far as the final is concerned, it's in our syllabus. The final exam is on, for some reason I thought it was Tuesday. Thursday, April 27th. Boom, right there. Thursday, April 27th, it will start at 4 o'clock, not 4:30. Like most of your exams, it's going to be 2 hours and 50 minutes. And so it'll go from 4 to 6:50. So kind of our end of our usual time, start a little bit earlier. A lot of it, actually, way longer than our usual class time. It's going to be 40 multiple choice questions. I will send all this details in writing to you all. 40 multiple choice questions. We've covered 11 weeks worth of stuff. So if you do the math, it comes out to roughly 4 questions per week. A couple of the sections obviously will have only 3 questions, because that's how the math works. So 4 of the sections will only have 3 questions. You won't know which. But basically the quicker sections, the simpler sections, the ones that have less to test on, will only have 3. You can basically guarantee there will be 4 questions for the last 2 things we talked about, since I want to make certain get tested on that, since it wasn't on the other 2 tests. Outside of that, if you all want to kind of calculate what you need in the class, so I will try to update the grades sometime in this next week. What you can do mathematically, if you want to see, it's a classic, everyone kind of does this in every class, maybe don't, maybe do. If you want to see what you need to get on the final to achieve a certain grade, you basically take your current grade, multiply it by 0.8, and then you just see, okay, I need this many points in order to get a, whatever grade you want to get, you divide that by 0.2. The final is worth 20% of your grade. So the way the math works out is it's 0.8 times your current grade plus 0.2 times your final grade. So you can kind of work out the math and figure out what you all need to get to achieve whatever score you want. With the reminder that the final exam will also replace your lowest test grade, assuming it benefits you. Your final grade will not replace your lowest test grade if it is your lowest test grade, because I'm not going to penalize you, double penalize you. Yeah. That's a great question. So the question was, because it's multiple choice, will the questions be harder? Largely no. It'll look pretty much the same. However, so I mentioned there's going to be 4 questions in each section. One of those questions may have like a couple steps in it. Maybe one of those 2-step problems. So an example of that may be that problem that we did with 2 wires and find the I give you the current in both of them, the distance, and I say find the force on the second wire. That's kind of a 2-step, find the magnetic field, then multiply by that. So you can expect one problem in each kind of thing to be maybe a 2-step situation. Maybe you solve for something and maybe you have to plug it in. So not nearly as hard as the free response. Maybe like half as difficult as the free response kind of thing. So a little bit more challenging, definitely not. But at the same time, I've already included some like that in the, yeah. Okay, let's see, what else is there? Next week is your last discussion section. Let me triple check that you all have on next week. If we go to our web courses, discussion, it's discussion 11. Nope, that's this week. Great, last discussion is this week. So this week is your last discussion. As far as grades we have left over, you have the quiz due at the end of this week on refraction and stuff like that. You'll have the quiz due at the end of next week on lenses. And then I believe, yeah, there's one more physics I care about just to kind of pad the grade a little bit. I do the third one just because if I only did 2 of them and someone missed one of them, it kills the grade. So there is one more physics I care about. Choose anything in the class. It'll take you no time at all. I chucked that third one in there because if I only did 2 of them and you missed one, it's going to kill your grade a bit. So I chucked that third one at the end just to give kind of some easy points, but don't forget about it. And I believe that is it. So we're going to finish up lenses today. Before we jump into that, I wanted to show you all this quick simulation because I've had some questions about critical angle. So I think I've mentioned this website to you all. I already have the tab open, but just to show you, PhET. Let's just go to the website. There's a website called PhET, P-H-E-T, and it's awesome. It's got it doesn't just have chemistry or physics stuff. It's got physics, chemistry, math, or science, biology. I'm going to go to the physics page and just show you how many different things they have. It says 0 results. There's more than 0. All these sweet things here that kind of let you see some of the concepts covered. So if there's any concept we've covered in this class that didn't make sense to you and you would like a visualization of it, I can almost guarantee you it will show up here. There's ones on electric fields, there's one on magnetic fields, there's ones on, again, a lot of stuff here we haven't covered, circuits, gas laws, charging fields, and you may find some stuff in here related to your other things. I don't know how much they have about biology. They definitely have more of an emphasis on physics, so there's a lot there. I know health science majors, so there's some, not much, but there is some PH. They're really, really good. Really, really good. So there's one on bending light. So it's refraction. It's got a laser pointer. You can choose the material you start with, the material you end with, and then you can take this protractor and kind of put it here to measure the angle. So you kind of have to manually do it, but you just line it up and it does it for you basically. So when we're talking about when we're talking about critical angle, we said you have to go from a more dense medium to a less dense medium. So we're going to go from water to air. And what you can see here is you can see that the angle I start with, if I go from a more dense medium to a less dense medium, if I start at 30 degrees, this angle is bigger. This is why the critical angle exists at all. As my angle of incidence, my angle 1 gets bigger and bigger, at some point my angle 2, you can see it gets closer and closer to the horizontal, and this is the critical angle. The critical angle is the angle at which the refracted angle basically reaches, I say basically, it does reach 90 degrees. So you can see it gets closer and closer, and at some point, no more light passes through the material. It's a really good visualization of that. The reflected angle was always here. If you all look at the surface of water, any surface, any interface between 2 materials, there will always be some amount of light that's reflected. That amount gets kind of bigger and bigger, and once you get to this point, it's all reflected. And once you get to reflection, remember reflection is super easy. The angle it hits with is the angle it leaves with. So if I put it at 60, it reflects at 60. Even when it's refracting in there, when it comes in at 30, it reflects at 30. So you can see all this, and you can see why if we have a less dense medium, to a more dense medium, it never happens. You never get a critical angle. When you have less dense to more dense, if this angle is 60, my second angle is less than 60. So it's impossible for this refracted angle to ever get. Now you'd be like, what about right here? Well, at this point, it's not entering material, so that doesn't count. But at any other angle, it never gets close because it's always smaller. So these are things you're playing around with. You can look at it as waves. I don't know, that makes it, wow, isn't that much more harder? Much more messy. But you can see the whole idea that they slow down. You can see the speed of them and see that they're slower in this water. And as I up the index of refraction, well, it's barely noticeable, but they get slower, even more slow. So, anyway, fun things to mess around with for any concept. This can be a studying tool if you're conceptually having any challenges with anything we've talked about. Just Google PhET, put the concept, and see if one exists. Can almost guarantee you it will. So, I wanted to show that real quick just to help explain that whole index of refraction business. It's got some more fun things you can play with, lasers or color and things. Anyway, I haven't really messed around with this. Try it out for yourself. Maybe you'll learn something new. Really, really good stuff. I love them. I use them in my high school classes all the time. In fact, we are doing a lab tomorrow in my high school class on refraction. So that's kind of what inspired me to do this. Mention it. So last class, we were talking about lenses. We talked about converging lenses and diverging lenses. We talked about how converging lenses converge light. Shocking. But what does that mean? It means that the light, let's go back to the picture, converging lens, light comes together, diverging lens, light spreads apart. And we basically said that there's some rules about them, that these make images, converging lenses make real images that can be projected on screens, diverging lenses make virtual images. You can't put it on a screen because the light never comes together, but your eyeball can see this virtual image. It perceives an image where the light rays, it thinks they're coming from. Your eye does not know how materials bend light. Like, that's not built into your eyeball. Your eyeball assumes all light rays are coming in a straight line. So if at some point light bends, your brain doesn't know that. When you look at a mirror and you're looking at something over there, you only know that that's over there because you're used to mirrors. But if you'd never seen a mirror in your life, you would think something's behind the mirror because that's what you're used to. Light travels in a straight line. And, I'm sure back in the day you could really spook some people. Go back and, well, I guess there's always water. Go to the desert, go back in time, spook some people. We talked about this equation, 1 over the object distance plus 1 over the image distance equals 1 over the focal distance. There's a couple rules. Object distance is always positive. Focal distance, positive for converging, negative for diverging. And then when you do the math, you find that the image distance ends up negative if it's a virtual image and positive if it's a real image, which means positive if it's on the other side of the lens, negative if it's on the same side of the lens. So quick picture of that. If we have a converging mirror and we're outside the focal point, bam, this is the case here. My image distance is positive. If we instead have, I attempted to draw that and I guess did terrible. If we instead have an object and we have a diverging mirror, these always make images that are right side up and over here. Object, image, this image distance, di, is negative if it's on the same side. So opposite side, positive, same side, negative. But that often comes out in the math. We did one clicker question where I said an object is located at 2 meters, if the magnitude of the focal point is 1 meter, what's the image distance of the lens is a converging lens. Let's do the same exact problem, but now it's a diverging lens. And I may chuck in a couple more clicker questions, just mix them up on the fly. Takes a little bit. So an object is located at 2 meters. If the magnitude of the focal point is 1 meter, what is the image distance if the lens is a diverging lens? My computer feels like it's got a lot going on in its life right now, so it's taking a little break. But you can still do the math while you're waiting. At some point it'll pop up a thing that asks me to share this, whatever. It will work. Great. Good job, computer. Did I do a whoopsie here? I may have done a whoopsie. Let's introduce a secret option which isn't listed here. This is why I always double check when I give you all these problems. Let's introduce secret option E, which you can't answer anything. Goodbye option B. Oh my gosh, computer. There we go. All right, wonder what it could be. Alright, I'll wait till 2:15 and I'm going to start solving it while it's open so we can see why I had to do that. Alright, 3, 2, 1, it'll stay open though. Alright, so let's write down our givens. Our object distance, let's close as many things as possible because it's chugging. Yeah, sure. I'm attempting to speed up my computer. So while this is doing its fun thing, one of the first things we have to, so the object distance was 2 meters. And so towards that end, if it's 2 meters, it's always positive. We always know, good, it's not doing better here. All right, we always know it's going to be 2 meter, the object distance is always positive. But the key here that was different than the last problem is that we're using a diverging lens. So because of that, so our object distance equals positive 2 meters. Oh, this is so slow. Object distance is 2 meters. The focal point is at 1 meter, but because it's a diverging lens, that's going to be negative. It's going to be negative, and so when we actually plug in the math, oh my gosh, what is... Sorry, y'all. I'm trying to bear with this, but it is so slow, so everything's going to close except, I guess, the streaming thing. And I'll just restart this and hope that whatever memory thing is happening here, maybe it's a simulation. Highly doubt it's a simulation. It's not doing anything. It's going to end up being negative 1 over 1 divided by, or minus 1 over 2. Yes, okay, great. All right, all the things are closed. Alright, I'm going to try the one with less rudder just to make it as least angry as possible.